Welcome again. We want to look at centripetal force, and as the word itself, it's a two combination word, that is centripetal and force. Force, you can remember from Form 1, that is, there's a topic in Form 1 known as force. Force, by definition, is a pull or just a push, and here centripetal force. So it's a force that acts on a body by directing the body towards its center. It is a force that acts on our body by directing the body towards its center. Now, if you can remember the previous video, you remember that we said acceleration acts on a body, that is centripetal acceleration acts on our body, and it directs it to the center, that is it's radial. Radial here means uh, radial here means the radius. Now, centripetal force, we want to derive it and see the formulae. Now, assume a body of mass m. Assume a body of mass m, and the mass, the body is moving around a circular path of radius r, and if you can represent v, that is it is velocity, and if it has its velocity, it will be moving towards a certain direction, that is it's moving around. Now, at every instant, in other words, at every point on the circumference, the velocity will be the same, but we agreed that the direction will be different, because at time it can be here and another time it can be here. Now, if we can represent that in terms of direction, now look at this velocity here, look at this velocity here. At time it is heading down, if I can say it, and at this instant it is heading north. So the direction is changing, but phi remains the same all through the circle. So due to that change, and I remember saying that velocity is a vector quantity, and so at every instant it will be changing direction, although the magnitude it will be the same. And also, if it's mass, now since mass also it is a magnitude, it is a scalar quantity, its magnitude is constant, so it will not change. If it's a mass of 10 kg, for instance, it will remain, m will always be 10 kg all through, as long as we don't have additional mass on the body. Now, and also, if you can remember that at an instant, that point, we can call, there's a point here A, we can put it here, and here we can put it P, so that from this point to this point it will be AB. That's our arc length, and it is subtending an angle theta at the center. And from our previous derivations, we agreed that theta, it is S over R, where S is the distance AB. So our S is equals to AB, that is the distance AB, and AB is our arc length. The arc length AB is subtending angle theta at the center. And also remember our derivation that omega was V over R. That's what we derived from our previous videos. And also we agreed that omega can be represented as 2 pi f, and f is our frequency, and frequency is revolutions per second. That's what we agreed. Now we want to derive our centripetal force, and in this case I want us to go back to Form 3, linear motion. And remember, when we started this topic, we agreed that the prerequisite topic or prerequisite information to this topic will be linear motion. So if you never understood that topic, I request you to go back and read it thoroughly. Now, in this case, from Newton's second law of motion, and I can quote it, it stated that the rate of change of momentum of a body is proportional to the applied force, and it takes place in the direction in which the force acts. Newton's second law of motion states that the rate of change of momentum of a body is proportional to the applied force, and it takes place in the direction in which the force acts. And that's why I want to represent F superscript C, that is F superscript C as our centripetal force, and also I will represent our centripetal acceleration as A subscript C. That's what I'll be using here. And now from Newton's second law of motion, we know that force is equals to mass times acceleration. And we had derived our acceleration, that is our centripetal acceleration, as v squared over r. That is our A, that is centripetal acceleration is equals to m, that is v squared over r. That's what we've derived. Now replace it here. You realize that our F, that is our centripetal force, will be, we said it is MAC, and our AC is equals to V squared over R. Now I want to replace all of these here. I want to remove AC in this. Then my centripetal force will be, V squared over R. That is the shortest way to derive it. That is, centripetal force is equals to mass times linear velocity squared, you divide by the radius. Another person will represent it this way. Now, because we got our centripetal acceleration as, remember we got our centripetal acceleration, that is AC, to be R omega squared. We can now replace it here. So our formula will turn to be, our centripetal force can also be written as, that is F C equals to M R omega squared. So these are the two formulas we'll be using all through as we move down. Now let's see some two examples here applying the same formula that we've derived. A ball of mass, so we have a ball of mass 2.5 multiplied by 10 raised to negative 2 kg, that is 2.5 multiplied by 10 raised to negative 2 kg. So that is the mass of the ball tied to a string, and the while is just to swing in an horizontal circular path at a speed of, so we have V is equals to 5.0 meters per second. So there's a mistake here. The question is supposed to be -1 here. You can change it to be -1, so that because if it is 5.0 m as -2, it means that is acceleration, and we are talking about speed in this case. So if the string is 2.0 meter second, in other words, if we are swinging that ball, the length of the string will be our radius. So the radius of that circular path that is being formed by the ball that is being whirled, that is our radius to be 2.0 meters. What centripetal force does the string exert on the ball? And if we are swinging a ball, the force that forces the ball towards the center, it is our centripetal force. Now the force, we are going just to apply the formula directly. Now we said our mass is 2.5, you multiply by 10 negative 2 kg, the velocity phi, and remember the velocity or the speed that is being quoted here is linear velocity, that is 5.0 meters per second. The length of the string we agreed is the radius, because if you swing it, the length becomes our radius, because it's the one that is tracing that circular path. So the radius is 2.0 meters. And from centripetal force, that is the formula, that is centripetal force represented by F subscript C is equals to mv squared divided by r. So I've just plugged in the numbers. So my mass is 2.5 multiplied by 10 raised to negative 2. I multiplied by the speed, that is 5.0. I squared it. I divided by the radius, which was 2.0 meters, and upon operation I get 0.1 Newton. Let me confirm it. And if you remember here, what I've done, everything is given in it is SI unit. That's why as I just never got a problem in doing it. That is 2.5 multiplied by 10 raised to negative 2. You multiply by 5 squared, that is 25. Then I divide it by 2, that is 2. You get 0.31 0.3125. So to 2 decimal places, I've written as 0.31 Newton. So in this case, my problem was so simple, because I was given every information was in it is SI unit. Every quantity, mass was in meters, velocity was in meters per second, the radius was in meters. So as long as everything is in it is SI unit, then my force will be newtons, and newtons is the SI unit of force. Now the second example is a car of mass 6.0 times 10 raised to 3 kg is driven around an horizontal curve of radius to 50 meters. If the force of friction between the tires and the road is 21,000 Newton, what is the maximum speed that the car can be driven at on a pavement without going off the road? Now let me give you 10 seconds. You can attempt it before I attempt, so that we can see if the answers are the same. So 10 seconds starts. Now let's go together. A car of mass, so I have the mass of the car to be 6.0 multiplied by 10 cubed kgs. The radius I'm given as 250 meters is the force of friction. So the force of friction, that is the force that is pulling that ball or that car towards the center. So it's the same as the centripetal force, that is 21,000 newtons. What is the maximum speed that a car can be driven at on a bend without going off the road? In other words, what we are missing is V. Now write down the formula. The formula of centripetal force, that is F, is equals to mv squared divided by r. I have F, I have M, I have R, but I don't have V. I have M, I have R, I have F, but I don't have V. So if I substitute the values here, I'll get 21,000, that is the force, is equals to the mass. The mass of the car is 6 times 10 raised to 3 kgs. I multiply by the velocity that I'm not given, that is velocity squared. I divide by the radius, which is 250 meters, and upon operation I'll get 21,000 equals to 6,000. You divide by 50, 6,000 divided by 250. 6,000 divided by 250 will get 24 v squared. Now divide by all through by 24, that is v squared is equals to 8 875, 875. Now find the square root both sides. You'll get v is equals to the root of 875. Root 875, you get it is 29.58. Now to nearest whole numbers, it will be approximately 30 meters per second. Now it is advisable in physics you write the SI units, and in this calculation you realize that there is something I've done here. So under v squared, I mean here there's something I've done here. V squared is equals to 21,000 multiplied by 250. You'd find by 6 times 10 negative 3. What have I done? What I've done, I've just now here. What I've done, I've just divided all through by negative this one. Now to find the reciprocal of 10 raised to 3 is just 10 negative 3. That's why you can see this thing here. So let's not complicate you. 21,000 has 3 zeros. That is the same as 10 raised to 3. So it will cancel with this one here. That's why you cannot see it in the next step. So v is equals to 21 times 250 divided by 6. And you get is just the root of 875 meters square per square second. If you are doing it from the above and using the same the units of force, mass, and the radius, you realize that you are to end up getting meter square per square second. And if you find the root, you will get 29.580 meters per second. Now to the nearest whole numbers, you will get 30 meters per second. And that is the end of that question. Now we can add something on top of that, and that is the factors that affect factors affecting the centripetal force. We have 3. The first one is the mass of the body. The second one is the radius of the path, and the angular velocity of the body. Now, if you want to know the factors, how they affect, we'll just write F is equals to mv squared over r. Now, as the radius increases, the force decreases. That is under the radius of the path. As the radius increases, the force, that is the centripetal force, decreases. Whereas as the radius decreases, the centripetal force increases. Now, you can remember that centripetal force is the force which keeps the body on its circular path. And that force, if the radius is being increased, then the force will decrease. Now, take this r because it is inversely proportional. If you keep mass and velocity constant, then it means that F c is equals to 1 over not equal, but here let me introduce the constant, the sign of proportionality, so that we may see how it is relating. Yeah, it's okay. That is F is equals to, that is F is equals to not equal, but 1 over r. This one is giving me a headache. Yeah, that is Fc is inversely proportional to 1 over r. That is the centripetal force is inversely proportional to 1 over r. So as r increases, centripetal force decreases. As r increases, centripetal force, it decreases. Now, what I've done is just I've taken m and v as the constant. Now, what if r is constant, v is constant? In other words, v is constant. Then if you see here, force will be directly proportional to m, because if I introduce the constant of proportionality, I'll get v squared over r, which we said were constants. Then if the mass increases, the force will increase. They are directly proportional. Force that is centripetal force is directly proportional to the mass of the body. So if I write it this way, it will be Km. K is the constant, and what we said it to be constant was V and R. So V and R are just constant. So I've represented them as K. Now, as M increases, if we increase the mass of the body, then the centripetal force will increase. And if we decrease the mass, the force will decrease. So they are directly proportional. Now, what about the velocity? What if we keep the mass constant, we keep the velocity constant? In other words, this time round our K will be represented by M over R. I'm taking phi squared and K here is just M over R. I've taken M and R as the constant. I'm taking the radius of the radius to be constant and the mass to be constant. Now, as the velocity increases, you realize that the force increases, and as the velocity decreases, the force also decreases. They are directly proportional. So those are the factors affecting centripetal force. Next moment, we'll be looking at centripetal, that is angular momentum. Thank you for watching. Be pleasant.